How to determine I naught with the help of Thevenin's theorem. Okay, so how can determine? First of all, we have considered here this one is a X and here Y terminal. Okay, that is X and here Y terminal. After that, clear? Our motto determine I naught with the help of Thevenin's theorem. So how can we determine? First of all, we have taken that is X. This node is X and this node is Y. Okay, and this 2 kilo ohm behave as a load resistance. That is behave as a load resistance. So you can assume 2 kilo ohm is a load resistance. So how can do it? First of all, this one remove and this whole circuit converted corresponding to Thevenin's equivalent. XY terminal is converted corresponding to Thevenin's equivalent. So how can do it? First of all, determine Thevenin's equivalent. Thevenin's equivalent means VTH. VTH is basically V of OC circuit. V of OC means XY terminal after open, then circuit look like that is 1 kilo ohm, here 1 kilo ohm, here 1 kilo ohm, and this one is okay, like this one. Better. Okay, here minus, here plus 2Vx plus minus Vx, here 1 kilo ohm, here 1 kilo ohm, and that is open circuit. Here 1 kilo ohm, here plus minus how much? 2 volt. That is 2 volt. Okay, and that is 1 kilo ohm, and this is open circuit. Okay, and now that is plus minus 6 volt, plus minus 6 volt. Clear or not? So our motto determine V of OC. So how can we determine? First of all, we have considered that is ductile node 0 volt. Okay, if you consider that is 0 volt, then if this one is 0, then what about if this one is V1 and that is V of OC and that is V2? Okay, so what about V1? V1 is V1 minus 0, this will be equal to plus 6, so V1 is 6 volt. Okay, and what about V2? V2 minus 0, V2 minus 0, this will be equal to 2, so V2 is written as 2 volt. Clear? Clear or not? And if this one is a V3, okay, but our motto determine V of OC. So how can you determine? If you apply KCL, here I1, here I2, okay, incoming current 0, outgoing current I1 plus I2, apply I1 plus I2, this will be equal to 0, put this value, I1 is V of OC minus V1 divided by how much resistance? 1 kilo ohm, plus I2 is V of OC minus V2 divided by how much resistance? 1 kilo ohm. Okay, so this is 0, V1 and V2 6 and here 2, so V of OC minus 6, 2 times V of OC, and V2 is with this be equal to 0, so V of OC finally we got that is 8 divided by 2, that is 4 volt. Clear or not? V of OC is 4 volt. Clear? So V of VTH finally you can written as V of OC, that is 4 volt. Clear or not? Very simple. Our motto determine VTH and RTH. First of all, we have focus on VTH. How can determine VTH? This one is open circuit. We have open circuit voltage, that is our Thevenin. Okay. After that, taken here I1, here I2 current, and before take I1, I2, we have assigned voltages. node voltages, that is 0 voltage, here V1, here V2, here V3, here V of OC. Because of V of OC this is 0, so that is V of OC. Okay, so V1 minus 0, this will be equal to 6, so V1 is 6 volt. And what about V2? V2 minus 0, this will be equal to 2, so V2 is 2 volt. Clear? After that, apply KVL in at this loop. Okay, I1 minus I2. Okay, sorry, I1 plus I2, this will be equal to 0. Incoming current is 0, because of that is open circuit, that's why. So V of OC is, finally we got, that is 4 volt. Clear or not? Now our next target is determine RTH. So how can determine RTH? First of all, make the circuit. I know that if you determine RTH means all independent source reduced to be 0. Okay, that is 0, it means short circuit, and that is also short circuit. Okay, so first of all we make the circuit. 1 kilo ohm here, 1 kilo ohm, 1 kilo ohm here, 1 kilo ohm here, minus plus 2 Vx here, 1 kilo ohm, that is short circuited, and this one is like this one, that is short circuited. And second one, that is voltage dependent voltage source available, and here 1 kilo ohm, here voltage dependent voltage source are available. So how can resolve this type of problem? I know that here 1 ampere source or 1 volt voltage source. If you take in plus minus 1 volt voltage source, then our motto determine I. Okay, or if you consider 1 ampere current source, then determine P. If you consider, someone take, no sir, I am taken 1 ampere current source. If you here 1 kilo ohm, that's why we have taken 1 milliampere. Okay, then we have focus on B. Clear or not? If you take 1 milliampere current source, then our motto determine V for RTH. So I know that how can determine RTH? RTH is 1 into RTH. V this is equal to basically 1 into RTH. If this one is, we have taken 1 milliampere, then what about RTH in the terms of in kilo ohm? Okay, if you got the answer, then this one is written as in kilo ohm. Why? Because of you have taken 1 milliamp. If you have taken 1 ampere, then if you got V is written corresponding to RTH, that is in ohm. Okay, clear or not? So how can determine? So basically our motto determine RTH. RTH is V. So if you determine V, then it is also written as RTH. Clear or not? So how can determine RTH? First of all, if this one is a ductum node, if you want again, if this one is a ductum node, it means that is 0 voltages. Okay, if this one is a 0 voltages, take here 0 voltages, it is also 0, so this one is also 0 voltages. Then what about voltage? That is V. Clear or not? Simple. And this, now here 0 voltage. If this one is 0 voltage, then we have taken here, that is V1. Clear? Now next target, our motto determine V. So how can we determine? If here I1 and here I2, apply KCL. Incoming current, that is 1 milliampere. 1 this equal to I1 plus I2. Clear or not? So 1 this equal to I1 is V minus 0 divided by 1, and V2 is V minus 0 divided by 1. Okay, V minus 0 divided by 1 and V minus 0 divided by 1. So what about V? V is written as 1 by 2. So what about RTH? RTH is 0.5 kilo ohm. Why? That is RTH is V. Basically RTH is V. So V is 1 by 2. I have already discussed. If you have considered here 1 milliampere, then if you, what about RTH? Finally we got RTH is in kilo ohm. So that is written as 0.5 kilo ohm, or you can say that 500 ohm. Clear? Now last target is plus minus VTH, here VTH, here RTH, and here RL is connected. Okay, and what about current? Our motto determine current. Very simple. What about VTH? We got 4 volt, that is 4 volt, and that is 0.5 kilo ohm, and this one is 2 kilo ohm. Clear? That is 2 kilo ohm. So our target is determine I naught. Our target is determine I naught. So what about I naught? I naught is written as VTH divided by 4 divided by 2.5. Okay, so 40 divided by 25. 40 by 25 means 1.6 milliampere. Clear or not? 40 by 25, or you can say that 8 by 5. 8 by 5, and 8 by 5 means 1.6 milliampere. Clear or not? So how can achieve the target? First of all, we have considered that is X and here Y, and this is load resistance, and this circuit converted corresponding to VTH and RTH. First of all, determine VTH, and after that determine RTH. Okay, then put this value and got the answer.